Good morning, everyone. In this video, we will be talking about derived data. Okay, we'll be looking at what are derived elements, okay, derived attributes, derived classes, and derived associations. Okay, let's look at them. A derived element is a function of one or more elements, actually. Okay, so basically, think about, say for example, you have an attribute. Okay, so which is actually say for example, there is a birth date is there. Okay, and then say for example you want to calculate the age of that person, so you don't need any further information. Okay, you need the date of the birth and then what is the current date. Okay, so that will actually give you this derived element which is age. Okay, so a derived element is a function of one or more elements which in turn may be derived. Okay, so for example the element themselves may be derived, and then you can actually have a derivation tree there. Okay, mostly a derived element is redundant because the other elements completely determines it. Okay, that is pretty obvious. Okay, say for example if you are modeling a class for a person, okay, something like that, most often you should not be putting the age when you have the date of birth as well. Okay, because in that way a derived element is redundant. Okay, because the other element completely determines it. Of course, if you have several derived elements, ultimately the derivation tree terminates with the base elements. Okay, say for example you can have a derived element and then from that one further derived elements and everything. If we go back across the tree, eventually you will basically end up with base elements. Okay, so the derivation can be at several elements. Actually classes, associations, and attributes may be actually derived. Okay, not just the attributes but also classes and associations. We will see that through examples. So I was talking about this derived attribute. Okay, I already gave the example. Okay, so which is like an age. Say for example, if there is a person, if you have a birth date and age, okay, and just by taking the current date, you can actually calculate the age. Okay, the age is actually current date minus the birth date. It is pretty obvious, isn't it? So there, the age is a derived attribute. Okay, so the notation for a derived element is a slash in front of the element. Okay, element name. Say for example here the slash basically shows it is a derived element. The constraint that actually determines the derivation must also be shown in this model. So the constraint here is age is equal to current date minus birth date. Okay, so this is the constraint which is actually on this sort of derived attribute. Okay, so that is the age. Hope that is clear. Now let us look at the other derived elements. Okay, so I will try to talk about these other derived elements through an example. Okay, so a machine will be composed of several assemblies. Okay, so we have also seen the composition. Okay, think that, and then an assembly is composed of several parts. Okay, so this is the basic application for you. But then say for example, so this composition will have an association class which actually defines, say for example in this one the names I have kept them simple, machine assembly and then part assembly. Okay, both the things. The point is say for example between the machine coordinates and the assembly, okay, there can be an offset. An assembly has a geometric offset with respect to the machine coordinates. The offset is something which has changed slightly. Okay, so that's the offset meaning action. Okay, originally say for example if a machine is there, a part should be, an assembly should be somewhere here. Say for example it has shifted slightly. Okay, so that's the offset. Similarly each part also has an offset with respect to this assembly coordinates. Say for example if this is the assembly and then there are several parts, even those parts are also slightly offset. But actually these offsets should be so small that you can still fit everything into this machine. If these offsets are too big, then so the assembly will not function. Okay, so you cannot basically combine all the things. Okay, so that is something which this application has to take care. Okay, so these parts is clear. So machine will be composed of assemblies and assemblies will be composed of parts. So you have this one to many relationship here. Okay, in the composition, and you have this associated class which is machine assembly and then part assembly, which are actually defining the respective offsets. Now think about the situation. Okay, at the part itself, we can actually define a coordinate system for each and every part that is actually derived by using the machine coordinates and assembly offset and part offset. Using that one, like you can actually define. Okay, so for each part, like you can actually define how far it has differing in terms of the complete machine is concerned. So that derived, you can actually represent that one as a derived offset. Okay, so that the coordinate system can be actually represented as a derived class. In this case, it is offset. That is why like you can actually see the slash. Okay, related to each part. That is what we are trying to do by a derived association net offset. For each part, like we are actually trying to have this sort of new coordinate system, which is like offset. Okay, which is with respect to this sort of coordinate system of the machine, and then like the offsets of both these assemblies and parts. Okay, and the association is like net offset. Hope that is clear. So since the class is basically slash offset, okay, so this is like again like a slash is kept here, and even for the assembly also like you keep the slash. So as I already have mentioned, like the constraint which is required, okay, so should also be mentioned. So the constraint for this offset is the offset is equal to machine assembly dot offset multiplied by part assembly dot offset. That's why, like, say for example, like if a machine is there, if the assembly shifts slightly and within the assembly, like the parts shift slightly, the offset will be actually multiplication of this offset for the assembly and then like multiplication with the offset of the assembly with respect to the machine. So that would be pretty huge. That's why like the offset should be as small as possible. In fact, actually they should be zero. Okay, then only like you can actually compose all the machine and then like you can fit all the things together. Okay, that's about the example. So a class model should generally distinguish these independent base attributes from the dependent derived attributes. Of course, we are putting the slash. Okay, when you look at the class model, you can actually see that they are differentiated by this having the slash. But then like you should be able to distinguish these independent base attributes and then like dependent derived attributes. Okay, we should also remember like including too many derived elements is actually not that much helpful. Okay, in fact it actually confuses us, it actually clutters the model a lot. Okay, so that is one important thing. So you have to include only those derived elements that are actually important for the application concepts themselves. Okay, and say for example the substantially ease implementation, then you can actually use such a derived element in your model. So regarding the reference again concerned, so still we are in chapter 4 of that object-oriented modeling and design with UML book. Okay, so thank you very much for your attention.